All right, so we worked really hard actually in that last video to develop a formula for a function which is itself a product of functions. It came out to be a somewhat complicated expression, which may be more complicated than you'd like it to be, but the point is, it's exciting, hell, it works. So if you have a function, no matter what that function is, if it is a product of two functions, you can find its derivative by using this formula. And that's pretty nice because when you add this formula to the formulas for sum and difference, now a function which is a sum of two functions, a function which is the difference of two functions, a function which is a product of two functions, you can compute the derivative. So what if you had p of x equal to square root x times 1 over x? Note, this function is a product of two functions. And since this function is a product of two functions, you can find its derivative using the rule that we came up with for products. So viewing this function as square root x times 1 over x, viewing this function as some function times some other function, you know how to compute the derivative. Carbon copy the second, multiply by the derivative of the first, plus carbon copy the first times the derivative of the second. It works every time, and it's going to work here too. So what's p of x? Carbon copy the second function is 1 over x, multiply by the derivative of the first. That's 1 over 2 square root x, right? That's something that we had computed previously. Put a plus sign in between, carbon copy the first function, square root x, times the derivative of the second. The derivative of 1 over x is minus 1 over x squared. And so if you sort of combine that and make it look pretty, you can write that as 1 over 2x square root x plus, actually we don't want to use a plus here because the terms that are multiplied in the last case have a minus sign in front of them, so let's do minus, and then we've got a square root x upstairs and an x squared downstairs, and there we go. We've now got a derivative for this function, which was a product of functions. And how do we do it? We use the product rule. Carbon copy the second, multiply by the derivative of the first, plus carbon copy the first times the derivative of the second. In this case, it turned out to be this guy, and that guy may look super complicated on the surface, but think about how amazing it is that what this formula tells you. Here's a function. You may not be able to know what this function looks like visually to the eye, like firsthand, without a graphing calculator or something to find what that function looks like. But in spite of the fact that we may not know what that function looks like, we now have a formula to compute the slope of its tangent lines everywhere. Kind of amazing if you think about it. And how we get it? We just use the product rule. Why? Because this function was a product of two functions. Here's another example that's a product of two functions. Anytime you have a function which is a product of two functions and you want to find the derivative, so here we've got y equal to this and we want to find y prime, we want to find the derivative of this function. Well, since this thing is a product, we use the product rule. And anytime you use the product rule, taking the derivative, you carbon copy the second times the derivative of the first plus carbon copy the first times the derivative of the second. That works every time. It's going to work here. So carbon copy the second function. The second function is x squared. Take the derivative of the first. The derivative of square root x, 1 over 2 square root x. This is something we computed previously. Carbon copy the first. That's square root x. Multiply by g prime. G prime is the derivative of the second. That, in our case, is 2x. And we've got it. You want to write this out sort of somewhat more cleanly, you could take these two fractions and multiply them. You'd get an x squared above and a 2 over square root x below. Take these guys and multiply them. You'd have a plus, 2x square root x. Now it sort of looks pretty. We'll put a box around it, and there's the result. But the long story short is, this function was a product of two functions. And because it was a product of two functions, we applied the product rule. The product rule may be a little bit cumbersome and a little bit clunky, but it's almost amazing at what it can do.